Okay, so this time we have radical equations. So the trick in radical equations is simply to put it back to the known equations, which is probably polynomial equations. So how do we do that? So in this first one, so we have here square root of x minus 2 equal to 2. How do we return that back to a polynomial equation? We simply square both sides. So by squaring both sides, we'll have here x minus 2 equal to 4. And let's just add 2 both sides to obtain x equal to 6. But the thing in radical equations is that you should always verify if your answer is indeed a solution. By that I mean, when we plug in 6 out here, will we get this? The answer is obviously yes, because 6 minus 2 equals 4. Getting the square root, we get 2. So this out here is the answer for this problem. So this first one is pretty straightforward. Next we have square root of x plus 5 equals 3. So we do the same thing. First, when we see radicals, we tend to isolate it in one side so that when we square, there won't be any radicals left. Since if we square this one already, you can easily check that there will be a square root left. So let's subtract 5 both sides. So we'll have your square root of x equal to 3 minus 5 is negative 2. And from here, you should actually stop already. So let's put here stop. And why is that? Because take note that when you get the square root of something, the value will always be a positive value. To be specific, the value will always be non-negative. But in this case, we have a negative value. So whatever value or whatever x we plug in out here, we won't really have a solution out here. So we can conclude out here that we have no solution for this. Again with the sad face. Okay, so that's for the 8th item. Let's go on to the 9th one. So we have your square root of 3x plus 7 minus 1 equal to x. Again, the trick, when we see a radical, we isolate it in one side. So let's move 1 to the other side. So we'll obtain here the square root of 3x plus 7 equal to x plus 1. And then let's square both sides. So upon squaring, we'll obtain here 3x plus 7. On the other side, this is basically a square of a binomial. So when we do that, we'll have your square of the first term plus 2 times the product of the 2 terms plus square of the last term. And then what do we have here? We simply have a quadratic equation. So we know how to solve that one. So let me move everything to the other side of the equation. So we'll have here 0 equal to x squared. Then we have here 2x minus 3x, that will be negative x. And then we have here 1 minus 7 out here, that would be negative 6. And then this one factors into, wait, let me just flip this one, just to make things visually easier for me. Let's just move this one, I don't really like the spacing right now. So this one will become equal to, when we factor this one, this is factored into x plus 2 times x minus 3 equals 0. And yeah. And then again, when we deal with this type, product of these two, we know that either one of them is 0. So we have here x plus 2 equal to 0 or x minus 3 equal to 0. But this one just simplifies to x equal to negative 2 or x equal to 3. Are we done? Again, not yet, because when we deal with radical equations, we must always check if these two indeed satisfy the given. So for negative 2, let's see. For negative 2, take note that clearly we'll have here negative 2. And then for this one, okay, let me put it down. 3 times negative 2 plus 7 is equal to 1. Get the square root, that will be 1. So this whole thing out here will be 1. 1 minus 1 is equal to 0, which is not equal to negative 2. Which means that this one is actually not a solution. We are left with x equal to 3. But if we plug in 3 out here, take note that we'll have here 3 times 3, that will be 9 plus 7. Get the square root of that one, that will be 4. Subtract 1, you get 3, which is the value of x. So I hope you were able to follow that one. So that means that this here is a solution, and so we can conclude that the solution for this item is just x equal to 3 and not x equal to -2. So again, you must always check in radical equations whether a solution is indeed a solution of the problem. Good, so let's move on to the 10th item. So we have your square root of 5x minus 1 minus x equal to 1. For this one, it might seem scary at first, but you just do the same trick that we have been doing so far. But first, you focus on this one. You disregard that there is a radical out here. So again, since it is already isolated on one side, we square both sides. So we'll have here square root of 5x minus 1 minus x, and fortunately, the square of 1 is simply just 1 as well. And then from here, this time this is our problem, this radical out here. So we isolate it to one side by moving this one to the other side. So we'll have here the square root of 5x minus 1 equal to x plus 1. And then we just square both sides. So when we square both sides, square this, square that, we get 5x minus 1 equal to square of a binomial. So we have here x squared plus 2x plus 1. And then let's just deal with this, like this is just a quadratic equation. So let's isolate everything to one side. I'll have here 0 equal to, move this to the other side, move this to the other side. So we'll be left with x squared plus 2x minus 5x, so that's minus 3x. When you move this to the other side, you get plus 1, so 1 plus 1, that will be 2. Good, let's just fix the spacing. And then from here, well, let's just write it again as this one so that it will be more familiar to you. And then so we have factoring. You can verify that this factors into x minus 2 and x minus 1 equal to 0. And then again, this just means that either x minus 2 is equal to 0 or x minus 1 is equal to 0. But this just gives us x equals 2 and x equal to 1. So is this the final answer? Again, we check. If we take x equal to 2, then we'll have here, let's see, 5 times 2, 10 minus 1, it's 9. It's 9, get the square root, this one becomes 3, and this one is 2. So 3 minus 2 is 1, get their square root, get 1. So good. Let's box this one. How about the other one? What if it is 1? If it is 1, then we'll have here 5x minus 1. That's 5 minus 1. That will be 4. Get the square root. You get 2 minus the 1 out here. That's 2 minus 1 is 1. Get their square root. You get 1. So again, this one is good. So fortunately here, we have 2 solutions. So that answers the 10th item. So let's move on to this 11th. Okay, good. So for the 11th item, we have here 2 radicals. 2 separated radicals. How do we deal with that? Well, you just choose one and then deal with the other one later. What I mean by that is, let's first focus on this one. So let's isolate it in one side. So we'll have here square root of x minus 1 equal to 1 plus the square root of x minus 2. And then here you just do what we've been doing. Square this both sides. So squaring this one, we'll have x minus 1, and then for the other side, square of the first term plus 2 times the square, or 2 times the product of these two, which is 2x minus 2, and then square the last one, which is x minus 2. So as you can see, we were still able to eliminate the problem into just one radical this time. And so let's deal with that one. But first, let's simplify it. So take note that this one on the left is x minus 1, and this one on the right, when you simplify, so we have here x minus 2 plus 1, that will give you x minus 1 plus 2 square root of x minus 2. And whoa, this is actually a good thing. Can you see why? Because technically the x's out here will cancel and -1 out here will cancel, which means that we'll be left with just, well, let's try it. 2 square root of x minus 2 equal to 0. 2 is just a constant, so we can disregard that one. We'll have here square root of x minus 2 equal to 0. And when is this true? When is square root of a number equal to 0? That happens if the inside is equal to 0. So that means that x minus 2 out here must be equal to 0, or simply x equal to 2. And again, let's check. let's see, if 2 out here, then we'll have 2 minus 1, so it's just 1. Then this one, 2 minus 2 is just 0, so this one is 0. Again, this one is 1, which matches this one. Which means that this one is indeed a solution to this problem. So again, in this item, we were fortunate that good. Then let's move on to the last one. Oh no, we have a fourth root out here. So how do we deal with that one? Well, just recall that this one, basically this one expression is raised to 1 over 4. And this one is raised to 1 half. So how do we put it in a setting that they'll have no radicals? We just raise both sides into 4. Because doing that one, so let's see what will happen. If we raise both sides by 4, so then I mean I do this, do that. We'll have here 3x squared minus 3x plus 1. And then on the right side, we'll have x minus 2 squared. And then let's just simplify this one. So we'll have here 3x squared minus 3x plus 1 equal to x squared minus 4x plus 4, square of a binomial. Then again, this is just a quadratic equation this time. So let's just isolate everything to one side and equate it to 0. So in here, let's move this one. So we'll have 3x squared minus x squared. That's 2x squared. Then out here, let's move this one here. So we'll have negative 3x plus 4x. That's plus x. And then finally, move 4 to the other side. So we'll have 1 minus 4. That would be negative 3 equal to 0. Again, do your trick out here. I use the slide and divide. This one will factor out into let's see, x minus 1, 2x plus 3. Is that right? Okay, so that just means that either we have x minus 1 equal to 0 or 2x plus 3 equal to 0. This one on the left simplifies to 1. This one on the right simplifies to negative 3 halves. And then are we done? Again, we are not yet done since we still need to check if this satisfies the given equation. And actually, it's not really hard to check that. These two actually doesn't satisfy. And why is that? Well, observe that if we choose 1 out here, then we'll have here 1 minus 2, which is square root of negative 1. That is an imaginary number, right? So that's already a fail. Then it's a fail because we don't really deal with those stuff out here. And we expect this to not result into an imaginary value. We're dealing with real values out here. And then for this one, you can also check that this one's negative 3 halves minus 2. Whatever the value is, it would be negative. So we'll have an imaginary value again, which means that we don't have a solution for this. Okay. So yeah. So basically, for this problem, we don't have a solution. Okay, good. So that's it for this part 2 of the equations that you should know by heart and to be able to master before college. Okay, good. If you don't have any questions or concerns or any good criticisms, then you can quit this video. But if you have, you can comment it down below and I'll be happy to read that one. So besides that, have a great day.